RGRல NEET கிளாஸ் படிச்சீங்கன்னா கவர்மெண்ட் கோட்டா சீட்டு உறுதிங்க. இல்லைன்னா நீங்க கட்டக்கூடிய ஃபீஸ் ரீஃபண்ட் பண்றோம். எப்படின்னு பாக்குறீங்களா? 20 ஸ்டூடெண்ட் தாங்க ஒரு பேட்ச்க்கு. 16 மென்டர்ஸ் வந்து 20 ஸ்டூடெண்ட்க்கு சப்போர்ட் பண்ண போறாங்க. 6 மணில இருந்து நைட்டு 10:30 வரைக்கும் இந்த கிளாஸஸ் போகும். இதுல நீங்க ஒருத்தரா இருக்க போறீங்களா? ஜாயின் RGR Academy.
Hello students, we welcome you all. Today we are going to discuss an important topic from the chapter 4 in your 11th standard of chemistry. So which is said to be the molecular orbital theory in the chemical bonding. So we know very well the VB theory and VS EPR theory. This happens to be a failure one because we're not able to get most of the informations about a molecule from those theories. So we switch over to the molecular orbital theory. And in what way this molecular orbital theory is helpful in finding the data about a molecule, and how we will be asked the questions in the NEET examination, so that we will discuss in this video. So in chemical bonding chapter, as I told you, the molecular orbital theory. So we usually represent this as MOT. So it was considered to be the most important theory in the chemical bonding. So what this molecular orbital theory says? So if the atomic orbitals has to combine and form a molecule, so these atomic orbitals, so according to the VB theory, it undergoes so intermixing and the electrons are transferred. That's what the VB theory says. But here the molecular orbital theory says the atomic orbitals of each and every element is specific, it is different. How the energies, different energy orbitals will combine together to share the electrons. So here the molecular orbital theory, so it says that the atomic orbitals, they combine and they form a new orbital which is said to be the molecular orbitals. So atomic orbitals of the elements, it combines together and it forms the orbital which is said to be the molecular orbitals. And this in this molecular orbitals, the electrons will be so filled and so results in the formation of a molecule. And how this combination occurs? The atomic orbitals, it combines to form the molecular orbitals, right? So how these atomic orbitals combine? So this atomic orbitals combines to form a molecular orbital. So using a method, so which we usually represent this as LCAO method. So which is nothing but the linear combination of atomic orbitals. So what is this linear combination of atomic orbitals is? It is nothing but the wave functions of the atomic orbitals, they combine together. Okay. The linear combination of atomic orbitals is nothing but it is the wave functions, combination of the wave functions of the atomic orbitals. How this combination usually occurs? So this combination, it occurs in either of the way. The first way where the wave functions combine is the wave function may add up together. So say for example, I have an atomic orbital of the element A. So the wave function of that atomic orbital, let us given as psi A. And I have another element, so which is said to be B, and that atomic orbital will have the wave function. Let me describe that as psi B. If these wave functions add up together, then it forms a constructive representation. It forms a constructive bands, constructive representations. It is nothing but, so say for example, you have the wave function of A to be this, and the wave function of the B will also be in synchronized with each other. So what does it mean? The crest of this B is the crest of this A. So what happens? You have the maximum probability of these electrons to combine together around the nucleus. The probability of finding the electrons will be maximum. That is why it is said to be constructive. So now this is said to be the bonding molecular orbital. When they are constructive, it is said to be bonding molecular orbital. So, or sometimes what may happen, so these wave functions, how they combine? They may combine to cancel each other. So how? So say for example, if psi A is the wave function of the atomic orbital of the element A and psi B is the wave function of the atomic orbital of element B, then it may cancel out each other. How it cancel out each other? It may form a destructive pattern. So how it forms a destructive pattern? For example, so this is the wave function of this A, and if this is the wave function of this B. And how we represent these two waves? We represent these two waves as out of phase with each other. So here this is in phase with each other, and here it is out of phase. It is not synchronizing. So you can see here the maximum of A is actually the minimum of B. So you don't have the probability of these electrons to bond together. So the probability of finding the electron is minimum in this case. So how the bond stability will be? The bond stability will be least in this case because we have the least probability of finding the electrons. So here in the bonding molecular orbital, so the bonding strength will be high. The stability of the bond is high. So here, when you have the molecular orbital of this form destructive, so the possibility of finding electron is very least and the bonding stability is less, this orbital, molecular orbital, is said to be the anti-bonding molecular orbital. And this anti-bonding molecular orbital will have very least stability. So we have two molecular orbitals. And how these molecular orbitals, they'll involve in bonding. So the molecular orbitals will involve in bonding in either of the case. So one, if it is in phase with each other, if it is along the nuclear axis, then it's said to form a sigma bond. So when it is the lateral overlapping, it is said to be the pi bonds. And according to the molecular orbital theory, so how these orbitals, it combine and form a molecular orbital, it depends upon the atomic number. So say for example, if you have an element which has the atomic number so lesser than 7, so it follows a pattern. Say for example, if it is lesser than 7, so let us consider the hydrogen molecule. So what will happen? One hydrogen atom, I have one s orbital with one electron. I have another hydrogen atom, so which has another 1s orbital with one electron. According to MO theory, so what we discuss, so linear combination of atomic orbitals. Two atomic orbitals combine together and forms two molecular orbital. So I told you one, it is of low energy and high stability, which is said to be the bonding molecular orbital, and the other one, so which has high energy and very less stability, which is said to be the anti-bonding molecular orbital. And here, so since this is 1s, so how the 1s electrons will usually bond together? So 1s, the shape of the orbital is spherical, right? So the overlapping will be along the nuclear axis, so this can form only a sigma bond. So this is said to be sigma 1s, and this is said to be sigma asterisk 1s. Antibonding orbitals are represented by giving the symbol asterisk. And now you have to fill the electrons in the molecular orbital, so by following the rules. So I hope you remember, so you have Hoffa principle, Hund's rule, Pauli's exclusion principle. So we use these principles to fill the electrons. So we follow here the same. So you have to fill the electrons in the lowest orbital first. So both the two electrons will be filled in the lowest energy sigma 1s. So the electronic configuration according to MO theory for hydrogen is sigma 1s2. So similarly, if it is less than 7, so how we can represent that for nitrogen? Because nitrogen involves the p orbitals also, right? So how we have to give, so nitrogen molecule, so for one nitrogen I have, so what is the electronic configuration? So 1s2, 2s2, and it is 2p3. So similarly, I have another orbitals also for the next hydrogen atom. So 1s, it contains 2 electrons. So 2s have 2 electrons, and 2p has 1 electron in each for the another nitrogen. So how these orbitals combine together? So first initially the 1s of one nitrogen and the 1s of another nitrogen, so they have to combine together. As I told you, two atomic orbitals form two molecular orbitals. One will be lower energy and one will be higher energy. So since this is 1s 1s, I told you you will have sigma bonding for the s orbital. So this is sigma 1s and this is sigma asterisk 1s. Okay. So how we fill the electron? You have 4 electrons, 2 in the lowest level and 2 in the highest level, and the lower first 1s orbital is filled out. So the next, so you have to follow the 2s orbital. So 2s orbital, again you have 2 electrons in the 2s orbital of 2 nitrogens. So 2 atomic orbitals combine to form 2 molecular orbitals, and one will be lower and one will be higher energy, and this is sigma 2s. As I told you, so sigma bond will have only nuclear axis overlapping, so it will form only the sigma bond. And this is sigma asterisk 2s, and 4 electrons, 2 in the lower and 2 in the higher. So 1s and 2s electrons, so this has been filled out. So how you will fill for the 2p then? So 2p, I hope you understand here. I write the orbitals from the lower to the higher energy. You have to write like this. So you should not write 1s from top to bottom, 1s, 2s and 2p. It's not like that. So we are, because 1s has the lowest energy, it should be written low and lower, and next the 2s. Now you have to go for the 2p. So since we don't have space there, I write here, but actually the orbital should come here. 2p. So in one of the nitrogen, 2p has 3 electrons. In another nitrogen, so 2p has 3 electrons. So 6 atomic orbitals are combining. So how many molecular orbitals has to be formed? So 6 molecular orbitals has to be formed. So how these molecular orbitals will be arranged? So it will be arranged like this. So 2, 1 and 2, 1. Okay. So this is said to be pi 2px, and this is pi 2py, and this is sigma 2pz. So why z alone? I hope you remember, ma, in p orbital. The p orbital is triply oriented, and one is 2px, if it is second shell, 2py and 2pz. And how this axis will be? So it will be like this. This is x-axis, this is y-axis, and this is z-axis. And if another atomic orbital is coming in a similar manner, only the z-axis can have the axial overlapping. So this y and y, it can have only the lateral overlapping. And this x and x can have only the lateral overlapping. And we have learned only the axial overlapping is said to be the sigma bond, and the lateral overlappings are said to be the pi bonds. So here, similarly, so the px and py will have the lateral overlapping. So that is why I have represented as so pi bonding. And 2pz, it will be the axial overlapping. So you'll be getting sigma bond. So these are antibonding orbitals. So this is pi asterisk 2px and pi asterisk 2py. And this is sigma asterisk 2pz. So totally 6 electrons. How we fill the electrons? So by following the Hoffer principle, Hund's rule and Pauli's principle, lower orbital should contain 1 electron each, and then pairing will occur, and then the lower orbital will fill. So totally the 6 electrons will be filled in the lower level itself. So here, using this, we can find out the stability of the molecule. So how we will find out the stability of the molecule? Using the calculation which is said to be the bond order calculation. So bond order is the number of electrons in the bonding level minus number of electrons in the anti-bonding level divided by 2. If this number happens to be fractional, so the stability is less, and if it happens to be 0, the molecule is unstable, and if it is a whole number, so the stability is high. So when you consider for nitrogen, so bonding orbital, you have 2 electrons, 4 electrons and 6 electrons, totally 10 electrons. Anti-bonding, so 2 electron, 4 electron, we don't have any here, so 4 divided by 2, which is equals to 3. So the bond order is 3. So the bond order is directly proportional to stability. So one of the nitrogen is bonded to another nitrogen by a triple bond because the bond order is 3. So since it's a whole number, and so the highest number, so the stability of the molecule is high. Similarly, if you want to draw the MO picture, so for the elements which has the atomic number, so same or less than 7, so you have to follow this. If the atomic number is greater than 7, then you have a slight change here. So what is the change? If you want to consider the element which has the atomic number which is greater than 7, shall we consider oxygen then? The next molecule, if it is O2. So electronic configuration is 1s2, so 2s2 and 2p4. 1s and 2s, it will be similar as what we did for nitrogen. But here this 2p alone, so it changes for the atomic number greater than 7. So how? See, the 2p of one oxygen, it has 4 electrons like this. And the 2p of another oxygen, so it has 4 electrons similar to this. So how these atomic orbitals combine to form the molecular orbital? So see, so now it is not 2 1 2 1, it is actually 1 2 in the bonding level and 2 1 in the antibonding level. So totally, so says 4 plus 4, 8 electrons. So how we fill? Again following the rule. So this is sigma 2pz and this is pi 2px and this is pi 2py. This is pi asterisk 2px, pi asterisk 2py. This is sigma asterisk 2pz. So totally how many electrons? 8 electrons. How we fill this 8 electrons? 1, 2, pairing here, 3, 4, 5, 6, again pairing here, and here 7 and 8. Okay. So how we will give the bond order? So bond order, so 1s and 2s is completely filled. Let us leave that. So here you have 6 electrons. How many electrons in the antibonding? 2 divided by 2, which is equals to 4 by 2, which is equals to 2. So one oxygen is bonded to another oxygen by a double bond. So here the bond order is a whole number and the stability of the molecule is also high. So this is the one small change, so which you have to follow for the atomic number which is greater than 7 while following the 2p orbital. So what are the important questions? So NEET kind of questions we can address from this topic. So this is a question which is asked in 2020 NEET paper, so which says that which of the following molecule has only pi bond? So which of the following molecules has only pi bonding? 1, C2. So the second option, it is BE2. So third option, it is N2. And the fourth option, it is O2. Okay. So this is the question which is asked. See, O2. I have already written the MO picture for the O2. You see here. Here you have the sigma bond. Here you have the sigma completely filled. And then the pi orbital also completely filled. So what happens to oxygen then? So the oxygen have the sigma bonding as well as the pi bonding. So this may not be the correct answer. So what happens to nitrogen then? So you can see here. A nitrogen we draw here, right? See? The pi orbital is also completely filled and the sigma orbital is also completely filled. So what are the bonds it has? It has sigma bonding as well as a pi bonding. So this is also a wrong option because it has both sigma as well as the pi. So now we have the doubt between this C2 and Br2, right? So shall we analyze the MO picture for that? Be2. So what is the electronic configuration? For 1 beryllium, atomic number is 4, right? 1s2, 2s2. 1s2 and 2s2. See, 1s and 2s, they both of them are s orbital. What bonding it will involve? It will involve only sigma bonding. So because s orbital is spherical in shape, so the overlapping will be along the nucleus. If it is along the nuclear axis, I told you it is a sigma bonds. You don't have any p orbital. You cannot analyze whether it has a pi bond or not. So what is the correct answer? Then it is C2. So how we arrive at that? So C2. So you can check 1s2, 2s2, 2p2. So 1s and 2s is completely filled. So let us assume that. So it has been filled in the bonding and the anti-bonding. We'll come to the 2p then. So because 2p isn't completely filled. So this has 2 electrons and another 2p have 2 electrons. So see, the atomic number is lesser than 7, right? So what is the pattern you have to follow then? So it has 2, 1 and 2, 1. Okay. So 4 electrons totally it has to fill. So this is pi 2px, pi 2py, and this is sigma 2pz. 4 electrons. How we fill? 1, 1 according to Hund's rule. And then pairing occurs. So here you can see the electrons are filled only in the pi orbital. So the sigma bond is empty. So it may not have the sigma bonding because no electrons in the sigma bonding, only pi bonding is there. So what is the correct option then? So here B2, it is not at all correct because it doesn't have any p orbital at all. And we find the right answer to be C2. So if you know how to get or how to arrive at the molecular orbital, we can easily assess these kind of questions. So I hope you have understand this.
RGRல நீட் கிளாஸ் படிச்சீங்கன்னா கவர்மெண்ட் கோட்டா சீட்டு உறுதிங்க. இல்லைன்னா நீங்க கட்டக்கூடிய ஃபீஸ் ரீஃபண்ட் பண்றோம். எப்படின்னு பாக்குறீங்களா? 20 ஸ்டூடெண்ட் தாங்க ஒரு பேட்ச்க்கு. 16 மென்டர்ஸ் வந்து 20 ஸ்டூடெண்ட்க்கு சப்போர்ட் பண்ண போறாங்க. 6 மணில இருந்து நைட்டு 10:30 வரைக்கும் இந்த கிளாஸஸ் போகும். இதுல நீங்க ஒருத்தரா இருக்க போறீங்களா? ஜாயின் RGR அகாடமி. நீட்டை கிராக் பண்ணி கூட நிறைய மாணவர்களுக்கு சீட்டு கிடைக்கலங்க. கவுன்சிலிங்ல சாய்ஸை சரியா ஃபில் பண்ண தெரியாம ஃபர்ஸ்ட் செகண்ட் ரவுண்ட்ல சீட்டை எடுக்க முடியலங்க. கவர்மெண்ட்டுக்கு மார்க் இருந்து கூட. அதனால நீங்க என்ன பண்ணும்? RGRோட எக்ஸ்பீரியன்ஸை யூஸ் பண்ணி கவுன்சிலிங் சப்போர்ட் எடுத்துக்கிட்டீங்கன்னு வச்சுக்கீங்களேன், ஈஸியா உங்களுக்கு ஃபர்ஸ்ட் ரவுண்ட்லயே கவர்மெண்ட் காலேஜ் சீட் கிடைக்கிறதுக்கும் பிளஸ் எந்த காலேஜ்ல ஃபீஸ் கம்மியா இருக்கு அப்படின்றத அனலைஸ் பண்ணி உங்களுக்கு சொல்றதுக்கும் ஆப்பர்ச்சுனிட்டியை பார்த்து உங்களுக்கு சாய்ஸ் ஃபில் பண்றதுக்கும் RGR ஹெல்ப் பண்றதுக்கு ரெடியா இருக்கோங்க. கால் பண்ணுங்க 8695186953. 12th முடிக்கிறப்பயே நீட் JEE கிராக் பண்ணணும்னு நினைக்கிறீங்களா? ஜாயின் RGR அகாடமி. எப்படின்னு பாக்குறீங்களா? ஸ்கூல் போயிட்டு ஈவினிங்ல கிடைக்கிற டைம், சண்டே கிடைக்கிற டைம் நீங்க இன்வெஸ்ட் பண்ணீங்க அப்படின்னா உங்களுடைய பிசிக்ஸ், கெமிஸ்ட்ரி, மேக்ஸ், பயாலஜி 4 சப்ஜெக்டையும் கத்துக்கிட்டு நீட்டையும் JEEயும் அழகா கிராக் பண்ணலாம். கான்செப்ட்ஸ் கிளாரிட்டி கிடைக்கும், அப்ளிகேஷன் ஸ்கில்ல டெவலப் பண்ணிக்கலாம், ப்ராப்ளம் சால்வ் பண்ற எபிலிட்டி வரும். இது மூலமா உங்களுக்கு நாலேஜ் கிடைச்சு அதை அழகா எக்ஸாம் பேட்டர்ன்ல ட்ரைனிங்கும் கொடுத்து டெஸ்ட்டும் கண்டக்ட் பண்ணி +2 முடிக்கிறப்பயே கிராக் பண்ண வைக்கிறோங்க. RGRல ஜாயின் பண்ணுங்க. கால் 8695186953.